Hello, welcome to another briefing. So in this briefing, I'm going to, per usual, start out with the satellite image. We're going to look at the western United States, and most of the northeastern Pacific, where our weather tends to originate, and then go into the western United States. I tend to focus on the western United States since I am based in the Bay Area. I do tend to focus in on this area, but I kind of try to do a broad brush of the general pattern of what's going on. And so what we're seeing here is we see a little weather system making its way through the Pacific Northwest. Right now, it's taking a bit more of an inland track. So here's our little trough in the jet stream here. The jet stream is basically that fast-moving river of air aloft, which is separating the warmer air to the south and the colder air to the north in the northern hemisphere. Of course, you have it opposite in the southern hemisphere. But anyways, you see here this clear trough in the jet stream. That's a dip. That's the cold air starting to come down from the Gulf of Alaska through most of the Pacific Northwest over here, and pushing through now pushing through Oregon into parts of Idaho, and this probably won't bring much, if at all, if any, rain to the Bay Area, for instance, because it is taking a bit more of an inland track. It's projected to do something like this, and with these kind of systems, you usually have most of the rain in the right front quadrant, which would be right here. So that's just not going to be very beneficial for the Bay Area because it's going to end up pushing inland. This is going to be sort of moisture starved. You're not getting a lot of moisture with this because you get a flow that's sort of out of the west, even a little west-northwest. And yes, it's moving over the water, but it's not really tapping into that warm subtropical air over here with these warmer waters to the south. It's pretty cold water, so that doesn't give us as much moisture as a warmer water would. For you to have an idea what I'm talking about, I'll use yellow here just to portray a fantasy scenario. If this system, and this was kind of what we had last week. Last week our system was more down here. Okay, it's set up like this. Here was the low and the trough was over here. Now you notice, like with this orientation, you have your flow more out of the southwest ahead of the low pressure system. You have a more favorable pattern for rain in the Bay Area. That's what we had last week. Your right front quadrant is right here, so favorable for the Bay Area. Today in purple, what we have, that's way further inland. That's not going to bring us much rain, if any. It'll bring us clouds, some wind. Do expect a lot of high clouds today. Expect maybe a little bit of breezy conditions. Don't expect really any rain if you're in the Bay Area. You could get some rain showers in Northern California, Crescent City, Eureka, sure. But not much. I don't think this is going to make it to the Bay Area, and anything that does, any rain that does make it down would likely evaporate before it hits the surface, because we have pretty dry air in the lower levels of the troposphere today. Let's take a quick look at temperature plots you're seeing, and wind as of the end. So I talked about those breezy conditions. You can see here 21 miles per hour is gusting at SFO, 20 miles per hour at Oakland, temperatures in the mid 50s. It's also cloudy out, as I showed on the satellite. Mostly, we had some areas dip into the 40s overnight because we had clear skies overnight, and that allowed for plenty of radiational cooling. That heat is lost quickly because the clouds aren't emitting their own radiation and keeping the ground from cooling that much. So clouds can counteract radiational cooling and act sort of a space heat, as a space heater in a way. So, but we go here and look at the camera, and you can clearly see. Let's look at these last 3 hours at Mount Tam in South Marin, and you can see there are those cirrus clouds, high clouds from that system to the north, streaming overhead. These are generally harmless clouds. They don't bring precipitation. They're just indicative of moisture in the upper levels. You see a little bit of that coastal fog, maybe a little bit of valley fog that developed in the lower elevations. You see that some wisps, some little patches of that showing up on the camera here. Um, and then this is a very complex, this is a sounding. This is basically taking a vertical slice of the atmosphere. You get these balloons launched twice a day, usually around 5 a.m. and around 5 p.m. on our local time here out of Oakland. This one is out of Oakland. And it gives you basically a snapshot of what's going on with the temperature and the wind and the humidity and all these variables at different levels of the atmosphere. And this kind of tells you where it's moist, where it's dry. It tells you all sorts of different stuff. But for the sake of simplicity, to not confuse people too much, I'll just show here. So the green is the dew point, which represents the saturation point, which is generally an indicator of how dry or how moist the atmosphere is. If you have lower dew points, you have drier air. And look at this tongue of dry air here in the lower troposphere. For reference, the 700 millibar level, it's about 10,000 feet. 500 is about 18,000. 300 is about 30,000. Here you go in 35,000 roughly. So you look here in between the surface and 10,000 feet, that lower troposphere, you're seeing a lot of dry air, particularly around the 5,000 foot level. That's what's going to cause your rain to evaporate. Any rain that does fall from up here you have a pretty moist, pretty saturated atmosphere in the upper levels, which is why we're seeing a lot of those high clouds. Here you have very dry air. So if the rain tries to fall down through here, it will likely evaporate by the time it gets to the surface. It won't reach the surface because of that. Also, you don't have a very favorable conditions for further cloud development because you have this inversion here with the temperature, where you have colder air below a layer of warmer air, and you're not going to get any rising with that. You have to have the parcel of air rising here has to be warmer than its environment, and that's not happening over here. We have a very stable environment in the lower troposphere here in the Bay Area. Now let's go ahead to computer model guidance. It's looking at what's projected to happen. Take it with a grain of salt when it's computer model guidance. This is just one computer model doing a bunch of equations, trying to figure out based on what it's seeing now, what it thinks will happen in the future. And we put this into motion. You see a lot of clouds. You're probably continuing to see some wind throughout the day in the Bay Area. And as I was saying here, Crescent City, Arcata, yeah, you'll get a little bit of rain today. But you go further south, this thing fizzles out pretty fast. And then by the time we get into early tomorrow morning, it's clearing out again. And we have clear skies throughout the day tomorrow. And then as we go into Friday as well. Let's do a quick overlook at the projected temperatures here. Over here. And we can see here mostly Central Bay Area and Central California looking mostly around 60 for the Bay Area, low 60s, maybe around 70 for the Sacramento area. But yeah, nothing too warm, really. Probably pretty much about average, what you would expect for this time of year. Could get a little chilly overnight, some 40s showing up again. I wouldn't be surprised if we get upper 30s in the coldest inland valleys. We'll have plenty of dry air, clear skies, a lot of radiational cooling, as we say. And then tomorrow afternoon, a little warmer, maybe some areas in the Bay Area getting closer to 70. Otherwise, for Sacramento, it'll be probably about the same as we had today. Um, and then as we go into Friday morning, maybe a little chilly again, and that model cuts off right around there. If we go ahead and look at the national blender models to give you an idea of high temperatures for the next few days. So here's today, here's tomorrow, a little warmer. Here's Friday, a little warmer than that, maybe mid 70s for some areas. And then Saturday and Saturday pretty warm also. And then Sunday maybe cooling off a little bit again. Monday, back into the 60s. Tuesday, we could have another little weather system coming through by then. I'm gonna hold off on looking at the guidance for that for now. Actually, you know what? I'll take a look at it, but do take it with a heavy grain of salt because it is just a projection, and when you go more than a few days out on these projections, there's a lot that can change. So do take it with a grain of salt. But this is our nationwide view of the longer range global model, the European model, the one that I tend to use. I will look at all the different models because it's important to do that, but for the sake of the briefing, the European tends to be the better model. So we're going to look at that one. And you can see here today, there's no precipitation, some valley rain, a little bit of mountain snow for some areas, mostly for the inner mountain west. You see that pushing through. And then, see, because that was a trough that I was talking about. And then here's this ridge, which generally brings us drier weather. We have warming air columns, we have drying air. So you go through Friday, Saturday, and then here we go. This is Sunday morning, 11 a.m. on Sunday. This projection for this model wants to bring that next cold front in. Now this would be a little more, that trough would be more offshore. This would be more of a favorable pattern for us to get some rain. And so there we could potentially get that rain, and that could have some showers lingering into Monday, Tuesday, and then so forth. And then when you go further than that, it's just really not worth it to look at model guidance when you're going super far out because a lot can change. But anyways, that's what I have for today. I hope this was helpful. I hope you were able to get something out of it. Thank you for watching, and I'll see you next time.